I welcome you to another video of fantastic data compression course. In this video, we will learn about Shannon-Fano coding. Shannon-Fano coding is an improvement over Shannon coding that we have studied in the previous video. Just like Shannon coding, Shannon-Fano coding is also an entropy coding. As explained previously, in entropy coding, we assign code words according to the probabilities of symbols. So, a symbol which has larger probability gets the smallest code. A symbol which is less likely to occur, that means that has smaller probability, gets a larger code. And that's how we achieve data compression. Just like Shannon coding, Shannon-Fano coding is also a prefix coding. Also, Huffman coding is a prefix coding. So, it is a prefix coding. What we meant by a prefix coding is that, for example, if symbol A has code word 0, then no other code word for any other symbol can start with 0, 1. For example, it is not allowed that B code word can be 0, 1, 1 because then B has a prefix of A code word and this is not allowed. So it is prefix free coding. However, 0, 1 can be at the middle of a code word or at the end of a code word. So it is allowed that B has a code word of 1, 0, 1. Shannon-Fano coding is not an optimal prefix coding scheme. We know that Huffman coding is an optimal prefix scheme. So Shannon-Fano coding produces less compression as compared to Huffman coding. You might be wondering that if it's not optimal, then why we should study it. The reason I think it is important to study Shannon-Fano coding is because based upon the ideas of Shannon-Fano, many other schemes were developed. For example, arithmetic coding used the idea of Shannon-Fano coding. Similarly, ANS coding and range coding use the idea of Shannon-Fano coding. Although Shannon-Fano coding is not optimal, but it is still worth it to learn it and know what's the idea of the Shannon-Fano coding. So let's do a small example so that everything is crystal clear. Before the example, another important thing that I forgot to mention is that Shannon-Fano coding is a greedy approach. That means the algorithm is greedy. That means at each step we find the local best option or local optimal option. Similar to Huffman coding, which is also greedy, where we also find local optimal option at every step. But Shannon-Fano coding is a top-down greedy approach. That means we start from the root node and we move towards leaf nodes. So the prefix tree that we will create, we will start from the root and move towards leaf. In contrast, in Huffman coding, we use a bottom-up greedy approach. That means we start from leaf nodes, our symbols are at leaf nodes, and we move towards the root node. In case of Shannon-Fano coding, local optimal choices do not translate to global optimal choice. However, in case of Huffman coding, local optimal choices translate into a global optimal solution, thus giving us an optimal overall solution. So let's clear the board and do an example so that everything is crystal clear. And in the example, we will also make prefix tree, which will start from the root and goes towards leaf. Here is our example. We are given symbols and their corresponding probabilities. We have to make sure that our symbols are sorted with respect to probabilities. In my case, they are already sorted. If you are given set of symbols which are not sorted with respect to their probabilities, then please sort them first. Now we have to divide this list into two partitions such that the difference of cumulative probabilities in both partitions is minimized. For example, if we draw a line here, then the sum of probabilities in the higher partition is 0.3, whereas sum of probability in the lower partition is 0.7. So the difference is of 0.4. In contrast, if we draw a line here, then the sum of probabilities in the higher partition is 0.55, whereas lower partition has 0.45. So the difference is much smaller. Similarly, we can say if we draw a line here, then once again the difference between the sum of probabilities in the higher partition and the lower partition increases. Therefore, our best strategy in this case is make a partition here. So this is our first step, and then we will assign symbols in the higher partition 0 and we will assign symbols in the lower partition 1. We will continue this procedure until each partition has only one symbol left. Now this partition has two symbols. We can only draw a line and create new partition in one way. That means we keep this symbol in the first partition and this symbol in the lower partition. Once again, symbol in the higher partition will get 0, symbol in the lower partitions will get 1. Now this partition has 4 symbols and we have to find a point where we can divide it into two sub-partitions where the sum of probabilities between these two partitions is the minimum. If we draw a line here, then this is the best choice, because if we draw a line here, then the difference between both partitions is not minimized. So in this case, I will draw a line here. I will assign symbols in the higher partition zeros and symbols in the lower partition 1. I'm done with these 3 partitions because they have only one symbol in it. However, this partition has 3 symbols, so I have to once again divide it into 2 sub-partitions. And once again, my best strategy is to draw a line here, because if I draw a line here, then this partition has 0.2 probabilities, cumulative probabilities, whereas this partition has only 0.05. So best strategy is to draw a line here. Once again, symbols in the higher partition will get 0 and the symbols in the lower partition will get 1. Finally, we have only one choice left to divide this partition. So we draw a line here and symbols in the higher partition will get 0 and the lower partition will get 1. So we are able to find code words corresponding to each symbols. So here we write our symbols and then here we write corresponding code words. Symbol A's code word is 0, 0. Symbol B code word is 0, 1, and they are prefix code words, so that no other symbol will start with 0, 0 and no other symbol will start with 0, 1. Symbol C code word is 1, 0. Symbol D code word is 1, 1, 0. E's code word is 1110 and F code word is 4 ones. Now at the end we have to imagine that how come it is a top-down greedy approach. Assume that your root is here. Now we combine all of those nodes with the root without any label. Then each of that code word correspond to different node of our tree. This is our prefix tree. And finally, from the root node, we are traveling to the leaf nodes. Therefore, it is a top-down greedy approach. At each step, we make the best decision by dividing the partitions into two equal parts. However, our local optimal solution does not translate into a global optimal solution. That is it for this video. See you next time. Bye.